Hello friends, I am Dr. Prof.Chishty and I am teaching physics to the BSc first year students. My today's topic is Michaelson Interferometer. Means when we are studying about the interference of light, then to obtain the steady interference pattern, we require two sources of light which are obtained with the help of a single source. Here it is an interferometer, means it will produce the interference pattern at the eyepiece. So let us see what type of apparatus. Very simple apparatus are used by the Michaelson, and he used a L-shaped wooden board, and on this board there is a screw is mounted. This is the screw is mounted vertically on this board. Then there are two mirrors, M1 and M2. These two mirrors are there. One is on the screw, one is movable, means this mirror can be moved up and down with the help of this screw. If you rotate this screw, this mirror, the position of the mirror can be moved up and down. But this mirror is fixed, M2 is fixed. Now there is one partially silvered glass plate, means a part will be refracted and a part will be reflected. There is a second glass plate, G, and this glass plate will adjust the path difference between the rays which are reaching to the mirror M1 and M2. Okay, so here is the source of light S. The light rays are made parallel with the help of a glass, and these light rays are allowed to incident on this glass plate, which will partially refract it and partially reflect it. So a part will move here, travel towards this mirror, and a part will be moved towards this glass plate. There is simple refraction in this glass plate and the ray will reach to the mirror M2. Now after refraction, these mirrors are highly polished mirror. After refraction, this light ray will be partially refracted towards the eyepiece. Here is the eyepiece, position of the eyepiece. So you can see the image through this eyepiece. Means microscope will be placed here, and with the help of this microscope you can study the interference pattern. Now as there is conditions of the coherence, monochromaticity all fulfilled, because only one source of light is used. Now see what is the working, how does it work. Now there are two rays which are coming to the eyepiece. One is which is reflected from the mirror M2, and another which is coming from the mirror M1. Certainly there is a path difference between the two mirrors. Means the fringes which are obtained in the eyepiece can be seen either circular or plane, or maybe field may be dark depending upon the position of the mirrors. Suppose here this mirror M1 and M2, these two are perfectly perpendicular. Then what will happen here? An air film is enclosed between these two, and you are going to observe the circular fringes. Such type of fringes will be observed in the eyepiece. Circular fringes will be observed. Now suppose if the path difference between these two rays is same, path difference is same, then what will happen? The field view will become dark if the path difference is same. Then there is total darkness. And if suppose mirror M1 and M2 are inclined, means they are tilted with the help of these screws. They are tilted towards each other. They are not perfectly perpendicular. Then such type of fringes, plane fringes, will be seen in the field view. Okay. Now what will happen if M1 is moved away or towards? If M1 is moved away or towards the eyepiece, means what will happen? If it is, we are rotating this screw and mirror M1 is moving towards or away, then there is a one fringe will pass through the eyepiece for each distance, each movement of lambda by 2. Means I am moving this one so that the M1 is moved through a distance of lambda by 2, then one fringe will pass through the field view. Okay. Now the types of fringes which we are seen in the which we can see in the Michaelson interferometer. Now we can see the circular fringes, we can see the plane fringes, or we can see the dark field view in the Michaelson interferometer. All depends upon the position of M1 and the image of M2 dash, means the image of the second mirror in the first mirror. So suppose here the light rays which are coming from the source S1 and S2, the angle between these two rays is theta. They are separated by a distance 2d. Then it is the path difference will become 2d cos theta. If there is 2d cos theta equal to n lambda, it is a condition for the maxima. And when this mirror, when these light rays are allowed to incident on the mirror M1 and M2 dash, M2 dash is nothing but the image of the first mirror, then we can see that there are circular fringes can be seen in the field view. But these two mirrors, if these two mirrors are coinciding with each other, then what will happen? If these two mirrors are coinciding, then the field view will become dark, and when there is separation between the mirror, again there are the fringes are seen. So the all depend upon the position of the mirror M1 and the image M2 dash. So if suppose these two mirrors, M1 actual mirror, M2 dash image, if this is the condition, means a wedge-shaped film is there, then such type of fringes are seen in the interferometer. See the type of wedge shape, the narrower point is towards your right, so such type of fringes will be starting from your left. Now if suppose these two mirrors are made perpendicular, means perpendicular to each other, or they are made in this position, then the straight fringes can be seen in the Michaelson interferometer. Now if I change the position of the wedge shape, that is this type of wedge shape is seen, M1 and M2 dash, then the starting point is towards your right and the fringes will be, circular fringes will be seen. So we can find the circular straight fringes or the dark field view by adjusting the mirror position of the mirror M1 and M2 dash. Now if suppose if I am using the white light, then very few colored fringes can be observed. If the path difference is very small, few colored fringes will be observed. Now what is the use of the Michaelson interferometer? We can find the wavelength of the light. First thing, wavelength of light used here. Then we can find the difference between the wavelength of the two neighboring lines. Then we can also find the refractive index of the material. Then we can find the thickness of the given thin film, thickness of the thin films. Then the standard meter, the meter which we are using in our day-to-day life is 1 meter long, means that length can be measured in terms of the wavelength of the light. Okay, so all these are the applications of the Michaelson interferometer. Thank you.